Hi everyone, welcome again to my YouTube channel Fitness Fit Community Geek. So in the last lecture, we have seen that the logic behind the multiplication of two matrices. So in this lecture, I will just show you the coding part. If you remember in the last lecture, it was too long, so that's why I just shifted it to another lecture. For better understanding, or it will be more cumbersome to understand the same logic in the same video and then code it out, because it takes too much time to explain it there. Okay, so now let's just open my logic here and let's start coding now. Microsoft Whiteboard, let's open it, and here, if you remember this, the logic here, using this matrix we design our logic, and the logic was, let me show you the logic here, where it's going. Yeah, so this was a logic, if you remember, to calculation of the summation and storing it another matrix, and using this logic we will now design our code. Okay, so just you might have just understand that how this works actually. And most important thing is, I will at the end just dry run it. Okay, I will take a matrix here and just dry run the code. Okay, let's me now open a code block IDE and just start coding. So Control Shift 10 for new file and save it as where we're gonna save. Just save in codes, YouTube channel codes, where I just do my codes, teach you guys here, and just save it as matrix multiplication mpterminal.cpp. save it, not cpp, sorry, it will be as actually C file, so that's why we will save it as matrix multiply.c file. Okay, so just include the header file as usual. Should I attach and just remain and okay, so what we have to do initially what we have to do, okay, let me show you that. So initially let me just dry run part here also. So first of all, we have to take the matrix A. Okay, so suppose this is the matrix A, so we have to take the matrix A, and I am going to design it for general matrix, means it can work for any matrix. So row and column we will take input at differently, and then we take the input of B matrix, which we have already done in the last lecture, if you remember, and just take the input from the user then. So now how are we gonna do it? So for that we will run one loop, for the taking this matrix as a input, and one loop for this matrix as input. Inside this there will be two loops. For each loop there will be two loops for for actually, if you remember, this I to n, and here another loop for j to n, because it's two-dimensional array actually. So and this is also, and we will take input at runtime input. Okay, so m and n, we will take row and column as usual. Okay, rows and column as you all know, as usual we will take it and just fit the input and according to this we perform our job. Okay, so just hop back into the code block. So what we have to do, we just have to declare variable like m, suppose m and n for rows and column. Let me just define a small int and column, and just print the message printf rows of matrix 1. So take the input as row or matrix 1 and save it in the variable m, %d, and variable m. Okay, so now after that just print a /n here, so that for readable purpose, and then rows of matrix, then ask for column of matrix, just store the variable. And so we have taken input. Now we have to declare one matrix. Suppose I already know that I will declare the matrix as A and M, A and B. Okay, so we just take the input. Now the rows and column have been entered. Now what you have to do, the values of matrix, so we have to print the message, always use /n. So now for that we will run one loop for int I equal to 0, I less than m, because we are firstly taking input as rows I plus plus, then take for column part for I int j equal to 0, I think you know this, guys. You have we are doing for this for a long time now, so it must be clear now. So what we have to do, just take the input first and dial D, and where are you gonna store it? We will store it the variable a of I and j. We just take the input out of first matrix and store it in the matrix A, and similarly we going to do for matrix B. So one thing you should notice that, I may declare x and y for two variables, but you, for your convenience, you know that, let me just get into that part. Okay, so you know that, you already know that I have told you matrix must be compatible, means say a of mn should be equal to, if two matrices are a and b, x and y, x into y cross x cross y, and n must be equal to x. This you already know. Okay, so this part will remain same, and this could be anything else. So just for that case, only I'm just again declaring, I'm declaring two more variable for x and y, but this must be, that compatible, means x should be equal to n in any case. Okay, so just remember this part only, or the matrix multiplication are not possible. Put the comment here. Take for matrix 1 part, matrix 1, and similar thing we have to do for matrix 2. So for matrix part, just copy this part and just change the variable, because it is similar to this. I know you have already seen lots. So just store it and change the variable as x and y, and create the matrices x and y. So just for one case, print a message to that if n not equal to, if not equal to x. So what do you have to print? Just print one message that multiplication cannot be performed, and just print this message. And else part, or you could do the thing here also, but because if x and y, to why there is no need to take the input. But yeah, suppose we are designing for general purpose, for someone want to perform addition, multiplication, you can just try menu driven function and you can write something else. So for that case we have to take the different matrix always. But this message will say, if user want to perform a multiplication, the matrices must be compatible, means the columns of first matrix must be equal to number of rows of first and second matrix, otherwise it's not possible. So else part we will perform the multiplication. Okay, condition checking. Hope there is no doubt, guys. Okay, so now for just simple case, just take three variable, three loops. We are taking m as means we have already declared two variable here, which is four variable actually, m, n, x and y. So for our main logic part, we are actually taking four variables. So how we gonna design the code for? So for that part we have to also declare one more matrix, okay, obviously, but filling.ij value, what will be the filling this ij value? Means I and j we will take according to what, as for that purpose our which I have already told you, that part which will come in handy. So I have told you that if there are two matrices of suppose this the case, if there are two matrices and they are compatible, then the resultant matrix will be the will have dimension, means we will get C matrix, or what, C will be get one matrix C after multiplication of and which will have the dimension of m cross y. Hope you're getting it. So which I have already discussed. Okay, so this case have to be handled. So how we gonna do it? How we gonna perform that? So we have to choose I and j according to this part, means for outer loop, for I equal to 0, I less than what, we will write here what, I plus plus, obviously, because we are running two loops. So first loop will the I part, it will fill this matrix. So for that case, what we will write here, I, what we will write the condition here. Okay, tell me, guys, pause the video and tell me, think about it. So hope you guys have think it. So we will write m here, so I will be less than m. And for the second loop, for this is second loop, for j equal to 0, j less than what, j plus plus. So what are we gonna write here? Okay, so pause the video for a moment and think about it. So hope you guys have think it. So we'll write y, because the resultant matrix must be the dimension of y. Okay, hope you're getting this. So by doing this, we are now completing the about a I and j part. And what will be the k part here? Okay, this is also the case which you have to handle. What will the k part? For k equal to 0, k less than what? K plus plus. So if you have seen other videos, you know, they will not teach you, they will not say you directly that. They will just directly took m and n for both the matrix and just you know, perform the operation. But I always recommend that, or try to go into depth of the subject topic, and always try to make a generalized program which will be helpful to, which will be needy in any case, which can be extractable for any case. So we are not making exception there. The both matrix have to be same dimension, means m and n. A must be m and n, and B also m and m. No, I don't want this. I want a different matrix, means m, n and m. So we don't, I don't want to design for this part. For that, this will remain same. No, I want to design for different parts. So what will be the k value here? So k value, can you tell me guys, what will be the k value? It will be n or not? Okay, so we have come to the point. It will be n. Why m? N actually, because we are, when we are designing this I, j plus plus our logic up. So we are designing a logic has, you know, a of, if you remember I, it will remain same, and here we are writing k plus multiply, sorry, and b of, you know, we are rewriting k, and here we are writing j. So for this part only we need to think about it. What will be this value actually? These two values. So hope you if you remember that the matrix, how the matrix work actually, will get the idea. So hope you remember the matrix, that there are two matrices and the values are, no. So what we are actually doing, we are multiplying this and multiplying this, means a11 into b11 plus a12 into b12. So it will actually form for entire row, means entire row of this, entire column of this are multiplied. So the k value are changing according to this. You can see that here it is 1 and it remain 1, but here it is 1 and it is changed to 2. You can see, and here this one is changed to 2. So it obviously is depend on number of, you know, columns of both the matrix. It will depend on not. Think about it. So when we are crossing this row, we are crossing the number of column of the first matrix, matrix A, and when down this, we are also crossing the number of elements in column 1, and which is equal to, we already know that this n and this number of column must be equal, n, both n must be equal. So for that case, we just take the n part here. Okay, so now using this logic, now you get to know that how we gonna fill these values. Okay, so let me just do it. So it will be m, we already seen that m, and which because of multiples, and just take the another loop for int j equal to 0, j less than what, y, already know that way, and j plus plus, and 4. Also one more thing to notice that if I take you know, y here, actually it's not affecting, and you might ask that it is dimension of other matrix, you know, actually it's dimension of second matrix part, but first matrix is independent of j. Okay, so it doesn't matter what we take here. So we will take, it will not, for without loss of generality, or it is obvious case, we can take y here and it will not affect the ith loop, eighth matrix anyhow, because a is independent of j, y, or the a is independent of you know, number of columns of second matrix. Okay, so if you are getting it, so it is very, you know, obvious thing to do. Okay, so now let's move into this. So I'm telling, giving you all the detail here. Okay, int I k equal to 0, k less than what value, n value. Okay, hope you remember this, and k plus plus. Now we just write the logic here. So we have to declare one more matrix. So what we have to do? So we have already taken m and n and x and y. So no need to do anything. Just to declare one matrix with dimension c of what, and dimension will be m and y or not. If you remember this, I've already explained it, this m and y. Okay, so m and y, obviously this will be another matrix. Just int it. This is our matrix, And for you can some programmer, some coder just initialize it with zero value, but you know it is local variable, so it will already contain zero value, so no need to initialize it actually, because we are not using the zero value anywhere. So c of ij will be what, plus equal to a of I comma k, because k is changing for a, because 0 0 0 1 and 0 2, into multiply with b of k comma what, j. Okay, hope it is clear to you guys now. So it's very easy. So after each passing of the row, means after each, means when we complete this loop, when this loop is completed, so actually we are making one cell here. One cell is completed for a one, after one cell, means this cell, means if this is 3 by 3 matrix, then first cell is completed now. So for that second cell, we just and the then y will increment it here. Okay, y means j value will increment it. First this loop is completed, then we will come into incremental part, and j will be incremented now. So if j will be incremented, that means we are just changing the column part here. Okay, this is first column, this second column, so we are changing, we are moving into the second column. So we'll again take the first row and multiply second column with second matrix. So for that case, we will just put one space here. Okay, because we are performing this row measure order. Okay, if you remember this. So every, after completion of every, this part is for one cell, this part is for cell, this part is for one column, column 1, column this, and this for row changing. Okay, so hope you are now clear. So when we are going to change the row, we need a slash n here. So when we row changing, means first row to second row, when we are moving from first row to second row, the row changing means row change is what, we just use slash n. Remember this point, not remember, just it's basic logic. And column change is always slash n. It is very obvious thing. Okay, slash t, which will space part. Okay, so remember this point, or just analyze this point. Okay, and coding is all about thinking. Okay, I am always telling you that, just think and do the code. So just write it here, after crossing one cell, slash t. And this completion of those, when we are in the outer loop, what are we going to do? So this loop is for one cell. Now we are going to change the cell. So whenever we change the cell, so what we discussed is, whenever we are changing this cell, when this part is over and we are printing this, and when this part is over, actually this part, so we are already changing the now row here, so we will be in second row. So for that part, just use slash t here, slash, sorry, printf, not print, we are not using Python here. So printf slash n. So this pretty much the whole code here. Okay, so we just need to now print this code. Okay, so for printing purpose, what we have to do, we just have to take two loop, and in a similar manner, we just have to take this two loop and use printf here. Okay, just copy it, and printing matrix multiplication. So just printing the matrix here. So just print one message to printf, just print the matrix there. After that, just paste the value and just change its scanf to printf percentile, not yeah, you can use percentile d, and because you are printing the values, and it will not a, it will now be what, c of ij. And after completion of every row, means we are taking input in every column wise. So first row, first column, means ij 0 1 and then 0 2 0 3 will be filled up, and yeah, you can use slash t here. And after coming out of loop, we just use slash n here. Hope you remember this part. This part is pretty obvious, slash n here. Okay, so now everything is fine. So this is pretty much the whole code. This is the main logic. So before running, guys, let me just print the matrix 1 and matrix 2 also. Okay, so copy this code, 1 for this, 2 for this only, and just print the matrix 2. It will be more readable then. So 2 matrix, and we just take the matrix, printing first matrix. So for readability purpose, okay, printing first matrix, so that you can see it, guys. And just change the value, don't forget to change the value here, slash a. And same for b part, printing second matrix, skip it, just change it to B, and also change the values are M and N, M and M. And also one more part is, the related matrix should be a chain of, so it will have dimension of, actually M and Y, M and Y. So also you have to make the changes in that case. Okay, so just change it to M and Y. Okay, just remember this small silly mistake can happen, to make it readable, more readable. Code must readable, that you don't unable. It's not like that in the next time you are referring to this code and you are unable to read it. So that's why, just readable purpose. Okay, so this is a pretty much code around here. Main logic is this. So now, so for also now let me just run it. Okay, hope there is no error. Okay, so 3 and 3, and just print as value 4 5 6 7 8 9. So first matrix is printed now. Okay, you can see it 1 2 3 4 5 6 7 8 9. Okay, and for second matrix, the matrix 9 8 7 6 5 4 3 2 1, this reverse order. Okay, so yeah, printed, and the second matrix printed, and the related matrix is this is the case here. You can see that the multiplication have been performed. One more thing is that, let me show you that case when matrices are not compatible. So suppose we take 3 by 2, there will be 6 element, 1 2 3 4 5 6. So yeah, and suppose now I take the rows of first matrix as 4. I have taken 2, so you can clearly see that these are not compatible. So 8 element will be there, 1 2 3 4 5 6 7 8. So you can see it's doing nothing, that this condition is checked that n is not equal to x. So in that case, multiplication cannot be performed, and it just exists out of the loop, terminate. Hope this is clear to you guys. So one thing you have to remember, the variables, when for this part, this is generalized, solution. So m and xy for four variable for 4 matrix dimension of rows and column, it's fine, actually fine. But whenever you are designing the logic here, just take care of the variable. Okay, if you are unable to do this, to just dry run this and check what could be the values here. Okay, no need to remember that every time. Okay, so just check it out, guys. Okay, so take care of these things, and j must be y and k must be n. Okay, so and just perform this part, and let me just dry run for you guys if you have any problem. And before that, let me just not use slash t here, it is making too much space. Just use simple space. Anywhere else slash t and space, don't use slash t, it's giving too much space. So run it now. 3 3 1 2 3 4 5 6 7 8 9. Now it is readable, and again 3 by 3 and 9 9 8 7 6 5 4 3 2 1. Okay, so second matrix, and the values are printed. So values are actually 9 6 8. This is the value. Just copy this part, and just add a note here. Okay. These are the value we have to perform here. Okay, so using this, let me just dry run the code. Okay, so it is not dry run, just actually multiply those matrices, we get the same result. Okay, so what were the element 1 2 3. So let me just multiply this part fast, very fast. I'm going to perform this very fast, so you guys can keep it up, you can do it too. So what will be the value? It will be 9 plus 12. So we are not getting the output actually. So can you do this? And for that part, you have to initialize the ij every time here. Okay, so just for sake, ij every time, ij make it to 0. Okay, which why I'm telling you that initialize is part, because if you don't make it 0, so you are getting at a point here, we are getting garbage value there because we haven't initialized this matrix. So we have to declare matrix, and we have to add every time it is in every row. So that's why now it will work perfectly fine. Okay, so now as we just modify the thing here, as you can see, yeah, we actually have to initialize this value. Earlier I was telling that no need, but you have to do that, because in C it doesn't work, but initialize is mandatory. It's mandatory to initialize the variables. So whenever we initialize it, and we can now use the plus equal to. Earlier I was not using plus equal to, that's why the only one value have been printed, the only one multiplicative value. But if you remember the logic, two have to be multiplied and then addition have to be done. That's why plus equal to necessary. So now our program will work perfectly fine. So let me run it now. So what we want to enter 3 and elements of matrix is 1 2 3 4 5 6 7 8 9. Okay, first element had been entered. Now for second matrix, entered element in reverse order. So here we go. This is the multiplicative value of both the matrices. So you can check it out, guys, how it actually works. So I have shown you a lot of examples, so you could have understand it how it really work. For now, you must understand. You must have got this how we get this value. Actually, it is from basic mathematical class. Just we have to do the coding part here. Okay, these are all no matter how multiplication is done of matrices was prerequisite, but although I just explain you guys. Okay, it take one more lecture, it cost me one lecture, but as I already told in the first lecture, I will go through the every concept in depth and I will start from scratch. That's my motto. That's my motto by designing this course, programming course, so that everyone could understand it deeply. Okay, so that was the pretty much whole code. So hope you guys like this video. So if you like this video, then subscribe my channel. You can subscribe my channel for more, and from next lecture we will see the pointers. Okay, so that was the last lecture. Finally it's over. Now the loop part is over. So we have done lots of lectures and lots of code on that. So hope that is clear to you guys. So from in the next lecture we'll discuss pointers, the most important topic of C programming. Remember that. So okay, so that's all for today, guys. See you soon. Bye, take care.